Right, this recording is to help you with lesson 1.02, graphs of functions. And we're going to start out with domain and range of a function first. Now the domain are your x values of your graph, and the range are all the y values of your graph. So if I have the function, the square root of x squared minus 1, I can graph it and take a look at the graph and determine the domain and range that way. So if I start out by doing that, the domain looks to be, well, I have a negative 1 here. So x is less than or equal to negative 1, and x is greater than or equal to positive 1. So I can state the domain that way, or you can do negative infinity to negative 1 and 1 to infinity. And the range are my y values, and it looks like the y values are only greater than or equal to 0. Because right here it's actually on the x-axis, so that is y equaling 0, and then above it. So I can state it like so, or I can say y is greater than or equal to 0. And I think most people actually prefer the x and the y written like this instead of your ordered pairs. But either answer is acceptable here. All right, the next one, let's determine whether the function is even, odd, or neither. Well, let's start by plugging in negative x into my function and see what I get. So I get negative x to the 6th minus 2 to the negative x squared plus 3. So negative x to the 6th, well, negative number to an even power is even, so or positive. So I get x to the 6th. There's my negative 2. Then I have negative x squared, so that's positive again. So I get negative 2x squared. And then I have that plus 3. Notice that that is the exact same thing that I started with. So because f of negative x equals f of x, I know that this is an even function. The next one is the same thing. It says sketch the graph of the function and then determine whether the function is even, odd, or neither. All right, it does not look like there's any symmetry here. So my graph is going to be neither even nor odd. All right, next, let's use a graphing utility to approximate any relative minimum or maximum values. All right, and we are going to be going over this one actually in the live class too, but we would use our graphing calculator and plug that in to get a graph that looks something like this. Now, a minimum is a low point. So here's a low point on my graph, and that looks like it's appearing at 1, negative 7. And a maximum is a high point on your graph, which appears to be right there at the point negative 2, 20. All right, next, let's determine the intervals, if there is any, for which the real axis, on the real axis, for which the function is greater than or equal to 0. So we're looking for where our graph is greater than or equal to 0. So when I look at my graph here, right here it's greater than or equal to 0, and right there it's greater than or equal to 0. So that would be when x is greater than or equal to 3, or x is less than or equal to negative 3. That's when my graph is above the x-axis. And then lastly, we're going to write h as a function of x for my rectangle here. Now, h is going to be the top minus the bottom, and I mean top function minus the bottom function. Notice you have two functions here, y equals 4x minus x squared, and y equals 2x. So h is the height right here. The top function is obviously this line right here, which is going to be your 4x minus x squared. So that's why we have it here for the top. And then the bottom, this is on the bottom of your rectangle, which is your 2x. So that's how we get 4x minus x squared minus 2x. Let's simplify. 4x minus 2x is a positive 2x minus x squared. And if you want to write it its highest degree first, you can. It would just look like that. So either one of these is an acceptable answer.